This is the Chapter 3 lecture supplemental video. So today's goal is the same. We're focused on we're focused on improving the mathematical reasoning by checking out some examples so that you can be a better problem solver. And then here is a tip I can give you at the beginning, right? So for this, in this chapter, the questions, the subjects you're learning doesn't seem that applicational, right? Well, the application will show up when you're taking the corresponding Math 146 or the future courses. So for now, I'll encourage you to treat a math problem as a game puzzle, like the app game, like Candy Crush or Angry Bird. The way you play the game is you solve each puzzle and then you challenge the harder one, and then right. Yes, the games are not easy at the later stages, but when you beat them, you'll gain the sense of achievement, right? So I'm encouraging you to have that same mindset when you do math. So treat an example as a game puzzle, and then imagine that you're like a professional gamer in training, and then if you get trained over time, then you'll be more and more skills in your profession. Think about that analogy. All right, let's start. Example number 1, simplify the expression. So when you see the keyword simplify, then we have to understand what it means in the math language again. It means we are going to literally simplify and make the expression shorter somehow. And then one thing we know is that we combine the like terms, right? So we have the H terms that are the like terms, and then the B term is another like term in the expression. And then the way we combine the like term is to add them up, right? We have negative 2h minus 5h, then just have to calculate the numerical factor, then you'll eventually get negative 7h, right? So all the like terms are additive. And then that being said, we have 2b plus b, which will give us 3b. And then the number right there is alone with no like terms. So that's why we leave it alone. And then this is how you simplify an expression. Let's take a look of another example. Right, so now we have an expression with either x squared or x cubed. And then keep in mind that if you have a term like x squared, then that means it's merely x times x. And then if you have a term as x cubed, then that merely means you're multiplying the x 3 times. So the symbols you're seeing right here, such as x, b, or h, they're just variables. And they all carry a value. So we just don't need to know what the value is in a variable, because we're just simplifying an expression. All right. So what are the like terms? The x squares are the like terms, and then we can combine them. So if we do that, then we will have 8x squared plus 9x squared plus 1x squared. And then the total will be 8 plus 9 plus 1, which is 18, right? I'm going slow to make sure you're following. So combine the first like term, the x squared term, then you'll have 18x squared. And then second like term is x cubed. So we'll have these 4 given, and then what we can do is to add them up again. We have 2 plus 1 plus 7 plus 5. I'll say this again, 2 plus 1 plus 7 plus 5. What would the answer be? 15, right? So the answer would be 15x cubed. So that's how you simplify an expression, and problem solved. All right, next, what about expand? So what does expand means? Well, that means you're expanding one term into, and then you turn that expression into one with more than one terms. All right, so if you have something like 9 as a factor in front of the remaining expression in the parentheses, that means we can expand by doing this. We can multiply 9 by every single part inside the parentheses. And why does it work? Because it is mathematically correct. And then I'll give you an example. If you have 2 times 1 plus 2 plus 3, so if you make up the first 3 part, if you make up the 3 parts as numbers, simple numbers, then things will make more sense. We have 2 times 6, which gives you 12, right? And then if we are expanding, then we're doing this to see that, right? 2 times 1 equals to 2, 2 times 2 equals to 4, and 2 times 3 equals to 6. And we add up the numbers, we'll get the same thing. So that's what I meant when I say the technique is mathematically correct. Okay, all right. Perhaps I'll change the color for more clarity. All right, so let's do the same thing. We have to approach in this hard way because we don't know what the x is. We don't know the value of x. That's why we have to expand. Right, so we have 9 times 2x to the 6. That would be 18 times x to the 6. That's the first term. 9 times 11x squared, that's 99x squared. Lastly, 9 times 4 in front of the negative sign, that'll be 36. So this is the expanded term. We're not simplifying. We should if there are like terms at the end, but the point is to expand the expression in this way. So remember this, we only have one term right here, right? And the expansion allows you to make up more separated term. And for example, we have 3 terms separated by the plus and minus sign with no bracket. And then, so when you expand an expression, then you will turn one term into multiple terms. All right, example number 4. Use the distributed property to simplify the expression. All right. So what it means is that you're distributing a number for problem solving. And then there are many ways to approach the final answer right here. So distribute is similar to expand. You're turning one fraction as one term into multiple terms. So these 2 keywords are similar. And then there is a way to turn this fraction into multiple fractions. And this is how, right? If we have 2 parts on the numerator shared by the same denominator, then we know that the numerators can be separated in this way, right? 6y plus 4 over 2 equals to 6y over 2 plus 4 over 2. Why does it work? Because it is mathematically correct. You can use the same technique to make up the number, like 3 plus 1 over 2. Then, first of all, we know that the answer is 2 if we calculate it directly. But if we use the distributed property, then you have 3 over 2 plus 1 over 2. Then you get 4 over 2, which is also 2. They're mathematically correct. That's what I meant. Right. And then if we do that, then we can now simplify the fraction. So we have 6 over 2, then that can be calculated by multiplying 1 over 3 on both, 1 over 2 on the numerator and the denominator. Or to make it more simple, we divide the two parts by 1 over 2, and then ends up getting a factor of 3. So the first term would be 3y over 1. And then 4 over 2 is already 2. So it's like 4 divided by 2. So we leave the result as 2 for the second part. And then we simplify the expression further, then the answer will be 3y plus 2. Problem solved. Right, so the key word is distribute and simplify. Example 5. Solve the equation algebraically. All right, again, what does solve means? Right, in the context of math, we have to understand the key word. So that means we're finding x. And then if we use the simpler English, then that means we're isolating x on one side of an equation. So now the result looks like x equals to something on the right-hand side. That's what that's what the solve means. And then there's an additional instruction. If your answer is a fraction, write it in reduced fractional form. And then the decimal is not allowed. So let's take a look. How do we isolate x? All right, so this is the question for you to practice, right? All right, so we have the x term combined. We have the x term with -4 on the left-hand side. So that means the left-hand side is not yet simplified. So we have to think about the way to make sure x is left alone at the end. So what would you do first? Pause the video and think about it. All right, I believe you have paused the video and then trust you. Then we'll proceed. What do? We manipulate the equation. We add the like terms or the same terms on both sides of the equation. That's how we approach the next step. And why would that work? Because -4 plus 4 equals to 0. So these two terms are canceled. And then eventually you'll get -2x equals to -6 plus 4. And then we can rewrite that equation again. Then we'll have -2x equals to -2, right? All right, so looks like the left-hand side is now simpler. And then we're almost isolating, we have almost isolated x. There's one more thing we should work on. This is a skill you all have to master, so I'll let you pause the video and think about it. What should we do? All right. I trust you. I believe you have paused the video, so let's go for it. Right. we divide both sides by -2 because the left-hand side will be divided. The -2 on left-hand side will be divided out. So we did it. We isolate the x, and then the right-hand side ends up being -1. So the answer is -1. There's no fraction. All right. Oh no, +1. My bad. Right. Sorry for confusing you. -2 over -2 equals to +1. So that is indeed the right answer. All right. So when you see the keyword solve, sometimes the example will be more clear. Right? It doesn't make a difference. Solve the equation for the given variable. And then obviously the given variable is x. Right? And then variable can be any value, but sometimes there'll just be exactly a certain value at in an example or in the puzzle. So as we happen to find x equals to 1 on the previous example. So we're going to practice another example, and then we'll see what x is. Right. So let's go over example number 6. All right. Now we have x terms on both sides. All right. What should we do again? Think about it. And proceed. Well, we have one part that isn't expanded yet. So the first thing we should do is to expand an expression whenever we see it. Now the previous concept is coming back, right? And why do we do that? Because we need all terms separated for problem solving. If you don't expand an expression, then you're not going to approach the right answer correctly. So 3 times 2x, 6x, 3 times 4x, 3 times 4, 12. Left-hand side equals to the right-hand side, which is -9x plus 8. Okay, right. Now you see that? Now this is when you have all the terms separated. Right. In the past, we only have 1, 2, 3 terms. And now we have 1, 2, 3, 4. So when x terms are separated in this way, this is when you simplify this is when you start isolating x. Think about it. Think about the mathematical reasoning. All right, then let's proceed. What should we do next? Right, we had to make sure the x term disappears on one side. Again, and the one way to approach is to add 9x on both sides. And then how would that work? It helps you cancel 9x, -9x with 9x on the right-hand side. And then another thing you can do at the same time is to take off 12 on both sides. So when you operate, you do the same thing on both sides. So these two are canceled. And then now you can add up these two lines. 6 plus 9 equals to 15. On the right-hand side, you have 8 plus -12, which equals to -4. Right equation, we have that. And then we do the division again. Divide the equation by 15. Do it on both sides, and then eventually we get the final answer. X equals to -4 over 15. And then we do follow the instruction and then show the fraction in the reduced form. right? There is no common factors to simplify the fraction further. So that's why this is an answer. All right. One last example. Solve for x. So we're finding x. Now we have several fractions, and then we have to think about what to do. All right. So here is a trick. So if you have different denominators in an expression, the first step is to eliminate denominators somehow. So remember, the denominators are 2, 4, and 6, right? So that means there is a common factor which allows us to get rid of all of them. And then that value happened to be 6 because all these 3 numbers has the same multiples as 6. 2 times 3 gives you 6 for no, not I took my word back. The common integer, the common factor as integer should be 12. That's the minimum possible, the minimum multiple shared by all the denominators. Because if you have 2 times the integer 6, you get 12. 4 times the integer 3, you get 12, and 6 times the integer 12, then you get 12. Right. So right, the other common multiple can be 24, but 24 is not the smallest one. It's not the minimum. So that's why we have to figure out the multiple as 12. And then this is how we apply the value 12. We multiply the given equation by 12 on both sides. And then let me show you how that works. So once you find that common shared multiple, then that means you're on the right track. And then again, the goal is to eliminate all the denominators. I know the other instructors have different ways, but this is my way. Right, 12, now we can expand the left-hand side and the right-hand side. All right, 12, first of all, 12 times 7 over 2x. What would that be? That would be 6 times 7x. Well, I'll make it easier to follow this way. You don't need to do the redundant step like that, but if you know what the answer is like, then you can continue and then skip this one. Right. So 12 over 2 equals to 6, right? So if you divide out the first term, then you have 6 remains. And then if you divide out the second term, you'll have the 3 remains. And then if you divide out the last term, then you'll have 2 remains. Right. So the first term would be 6 times 7x. And then the second term would be 3 times 5. The third term is 3 times 12. And then the fourth term would be 5x times 2. Right. Now we have got rid of all the denominators. Right. Rewrite the equation. You have 42x plus 15 equals to 36 plus 10 times x. And then we simplify the equation. For example, we take off 10x on both sides of the equation to cancel these 2 guys. And then we take off 15 on both sides of the equation to cancel these two guys. And then what do we get at the end? Right. We're isolating the x now. So 42 plus -10 gives you 32. And then 36 plus -15 equals to 21. Right. Eventually divide the new equation. 32s are divided out. So you have x equals to 21 over 32. You can simplify the fraction further. So this is the final answer. All right. I know there are other ways of problem solving on this one, but believe me, they're not going to be easier than this. And I can show you exactly what I meant. Right. So for example, if you have the original given expression, then sure you can isolate the x by taking off the fraction on the right hand side, and then yes, you can also subtract the equation by 5/4 on both sides of the equation. So yes, these two terms are canceled and these two terms are canceled, but you know what we are getting to? You are getting the expression as 7/2 minus 5/6x, which equals to 3 minus 5/4. That doesn't look easier, right? And you still have to figure out the common denominator. But if you want to approach it that way, that's fine, right? Just find the way of problem solving you're more comfortable with. All right, so make sure you practice some problems, redo the homework with similar problems, and then that's how, and then finish the quiz. I'll see you next time.